Module 3, Building in the Cloud. In the last module, we talked about fundamental resources in any IT environment. What's beyond servers and storage? Fundamental services like Amazon EC2, Amazon EBS, and Amazon VPC make it easy for organizations to acquire and build IT systems using familiar technology. However, they still have to architect their applications to take advantage of the elasticity of the cloud. So here again is our simple web application hosted in AWS Cloud. However, there's a limitation of a single EC2 instance, which doesn't grow for us when we need more capacity, doesn't reduce its footprint when usage is low, and it's hard to optimize a web app and database on a single machine. So how can we optimize this application to run on AWS? Amazon CloudWatch is a monitoring and metrics service. It collects telemetry from AWS resources, as well as custom resources, and computes statistics or CloudWatch metrics you can use to monitor your environment. You can use CloudWatch metrics in conjunction with CloudWatch alarms to send notification or automatically trigger workflows about changes in your environment. So how does CloudWatch work? Amazon CloudWatch ingests metrics from your AWS resources and customer applications, in which you can then create CloudWatch alarms when a statistic hits a certain threshold to send out notifications or trigger Amazon EC2 autoscaling. Managing demand efficiently. In a traditional data center environment, the scalability of your system is bound by your hardware. To host an application for a given week, we would need to provision enough capacity to ensure we can serve our customers. In this case, we would need to provision enough for Wednesdays, leading to waste. Amazon EC2 autoscaling allows us to provision and terminate EC2 instances dynamically, allowing us to scale out for spikes and scale in during off-peak, as well as replacing unhealthy instances. How does EC2 autoscaling work? Using CloudWatch alarms, we can watch a certain metric on our EC2 instances, such as CPU utilization. We can configure these alarms to trigger when either the CPU is too high or above 60%, or too low or below 20%, in which when the corresponding alarm triggers, we configure autoscaling to add or remove EC2 capacity, therefore automating the scaling of our infrastructure. So how do you handle fleet management with Amazon EC2 autoscaling? If you run multiple EC2 instances, typically we call this a fleet. Amazon EC2 autoscaling can check our EC2 instances to make sure that they are working by performing health checks, in which if an instance fails a health check, autoscaling will replace that instance with a new one, giving us better resilience or fault tolerance. Elastic load balancing. Using CloudWatch and EC2 autoscaling allows us to be more fault tolerant, cost efficient, and performant by adding and removing or replacing EC2 instances. With this fleet of EC2 instances, we need a way to direct traffic to these new machines. A typical strategy is to use a load balancer. Amazon ELB or Elastic Load Balancing is a highly available managed load balancing service and supports health checks, SSL, TLS, and monitoring. Today, Amazon ELB supports 3 different kinds of load balancers: Application Load Balancer, or ALB, Network Load Balancer, or NLB, and Classic. Application Load Balancer example. So ALB is a layer 7 load balancer or HTTP HTTPS load balancer for web application and supports path-based routing, or routing based on the contents of your requests. It supports various targets today, such as EC2 instances, Docker containers, and external sources. The other main load balancer is Network Load Balancer, or NLB, and it is a layer 4 load balancer for all other applications, and today it supports TCP, TLS, as well as UDP. It's great for applications that need a single static IP to route traffic to. Deploying database services. Do it yourself versus AWS Database Services. There are 2 main ways to run databases in AWS. You can provision and configure an Amazon EC2 instance in which you're responsible for the scaling, high availability, and maintenance of that resource. Or you can simplify it by using a managed database service in which AWS manages the scaling, high availability, and maintenance for you. So one of these database services is Amazon RDS, or Relational Database Service. It makes it easy to set up, operate, and scale a relational database. Today, it supports Amazon Aurora, which we'll talk about later, PostgreSQL, MariaDB, Oracle, MySQL, and Microsoft SQL. It reduces the administrative burden of running your own databases by automating things like patches and backups. Supports snapshots for redundancy and multi-AZ deployments for high availability. What is Amazon Aurora? I mentioned Amazon Aurora in the last slide. Amazon Aurora is an enterprise database built to natively take advantage of the elasticity of the cloud. Today, it supports MySQL and PostSQL out of the box. It's up to 5 times faster than standard MySQL deployments and 3 times faster than standard PostgreSQL deployments. Amazon Aurora features a distributed, fault-tolerant, self-healing storage system that automatically scales up to 64 terabytes per database instance. It delivers high performance and availability with up to 15 low-latency read replicas, point-in-time recovery, nearly continuous backup to Amazon S3, and replication across 3 availability zones. The other database is Amazon DynamoDB. Amazon DynamoDB is a fully managed, fast, and flexible NoSQL database. It's built for low latency, with average service side typically in the single-digit milliseconds. As your data volumes grow and application performance demands increase, DynamoDB uses automatic partitioning and SSD technologies to meet your throughput requirements and deliver low latencies at any scale. So what's a use case for DynamoDB today? DynamoDB is used in many places today, such as serverless web applications, microservices, mobile backends, ad technology, gaming, and IoT or Internet of Things. In addition to what we discussed, AWS has services for data warehousing, such as Amazon Redshift, graph data, such as Amazon Neptune, and for MongoDB compliant workloads, Amazon Document DB. To help you move data, we have AWS Database Migration Service, or DMS, which makes it easy to migrate database to AWS quickly and securely. Today, AWS DMS supports homogeneous migrations to the same database engine, as well as heterogeneous migrations for different databases. The right tool for the right job. There are many options in AWS for databases today, and not one works for everything. If you need an enterprise-class relational database, choose Amazon RDS. If you need a fast and flexible NoSQL database without the need to scale, use Amazon DynamoDB. Need full customization? You can always run your own database in Amazon EC2, as well as specific use case-driven databases for machine learning, data warehousing, and graphs. Automate deployments. What is AWS CloudFormation? AWS CloudFormation is a service that makes it easy to create repeatable, deployable models of your infrastructure, allowing to capture your infrastructure as code or templates. First, you code your template describing your infrastructure. In this case, would include our VPC, subnet, internet gateway, and security for our network, and a single instance to run our application. So, going back to our original application, a simple web application hosted on an EC2 instance backed by S3 and EBS for static content and database storage. We can replace the EBS volume or database component of our application with Amazon RDS to get better performance and reduce administrative overhead. To take advantage of elasticity of the cloud, we can use Amazon CloudWatch, elastic load balancing, and auto-scaling to get better scalability. Finally, we can capture this design by creating a CloudFormation template so that we can redeploy the same architecture again and again if needed. Did everything we talk about sound complicated? Want a simpler way to do the same thing? For certain workloads that fit a 2-tier architecture, we have AWS Elastic Beanstalk, which makes it simple to set up and deploy web applications on AWS. You just give AWS Elastic Beanstalk your code, and it handles the details of infrastructure provisioning, high availability, and load balancing and monitoring. allowing you to focus on your application. Connect and share data. Have an on-premise data center and need a way to connect it to AWS to either extend your capacity or migrate your workloads? Connecting it over the internet has limitations, such as network, storage, and communication challenges. Therefore, we have AWS Direct Connect. AWS Direct Connect is a dedicated network connection from your on-premise to AWS, providing fast and private connectivity to AWS. So how does AWS Direct Connect work? We have various Direct Connect partners around the globe in which we have deployed AWS Direct Connect infrastructure, in which you can provision a fiber connection to our partners, which connects you to AWS Direct Connect, allowing you to bypass the internet, getting a faster, more reliable path to AWS services. What is Amazon Route 53? Amazon Route 53 is a highly available and scalable domain name service or DNS web service. You can use it today to register domains, route internet traffic to resources based on geolocation, weight, and health checks. Here is an example of how we can use Amazon Route 53 to host our domain, sales.example.com, and route it to our application hosted on EC2 instances behind an ELB. What is Amazon EFS or Elastic File System? Amazon EFS or Elastic File System is a fully managed, scalable, elastic, cloud-native file system for Linux. EFS scales for you, so you don't have to worry about data limits or performance, making it easy to implement a shared file storage. So putting it all together, continuing with our web application before. Instead of all our application data stored on EC2 instances, we can now centralize it by storing it in EFS with connectivity through Direct Connect to on-premise resources. Deliver content faster. In this example, rather than improving on existing environment, you will build a cloud-native architecture. The requirements for your solution are shown in this design. You can meet most of these requirements by using AWS services that you have already learned about. But there are additional services in this topic that will make your architecture faster, more scalable, and more cost-efficient. So one cloud-native service is AWS Lambda. You can use AWS Lambda to run code without provisioning or managing servers. You only pay for when your code is running. You upload your code to Lambda, and Lambda takes care of everything required to run, such as scaling and high availability. AWS Lambda is an event-driven service, allowing you to automatically trigger from other AWS services, or you can call it directly from any web or mobile application. Today, Lambda supports a lot of different languages such as Java, Node.js, C#.NET, Python, Ruby, PowerShell, and any other custom language using Lambda layers. Lambda deals with administration, tolerance, and orchestration, allowing you to focus on your code and your application. So how can we use AWS Lambda? Here is an example of how we can use AWS Lambda to process and generate thumbnails for images we upload into S3. We can configure S3 events to trigger AWS Lambda functions, which can be code we develop to generate a thumbnail. The execution role here gives permissions for our AWS Lambda functions to talk to Amazon S3. What is Amazon Simple Notification Service, or SNS? What services can trigger AWS Lambda? One service is Amazon SNS, or Amazon Simple Notification Service, which is a broadcast or pub sub service that allows us to reliably send messages to other systems, such as Amazon SQS or Simple Queue Service, AWS Lambda, as well as HTTP endpoints, email, SMS, and push notifications. Amazon SNS will manage scaling and infrastructure required. You just focus on how you want to configure where your messages need to go. How does Amazon SNS work? To configure Amazon SNS, first, we need an Amazon SNS topic, which is a channel we use to map our producer or publishers to our consumers or subscribers. Whenever we publish a message to an SNS topic, Amazon SNS will then send out that message to any subscribers of that SNS topic. What is Amazon CloudFront? Amazon CloudFront is a fast content delivery network that you can leverage to quickly and securely deliver content around the world. It integrates with AWS Shield, our DDoS mitigation service, and supports Amazon S3, ELB, or Amazon EC2 as origins for your content. Today, Amazon CloudFront has over 166 edge locations around the world that you can use to accelerate the distribution of your content. How does CloudFront deliver content faster? When a user requests for content without a CDN like CloudFront, that would mean going to the origin. For instance, a customer in Singapore making a request to services in which you host in the Singapore region would get media quickly. However, if they travel to Japan, now their request would have to travel much further on the internet to reach your origin. What CloudFront allows us to do instead of going across the internet, which is unpredictable, with CloudFront, we can go to the nearest edge location. So in the last scenario, instead of our customer in Japan going to Singapore to get their content, they would now go to a CloudFront edge location located in Japan. CloudFront is a lazy loading caching system, meaning that it will only load content into the edge location when it is requested for. Therefore, in this scenario, the first time our customer in Japan asks for that content, it won't be loaded into the Japan edge location. Instead, CloudFront will load it behind the scenes and populate the cache, then serve it, meaning it will be ready for subsequent requests, making it faster. So we just talked about how we can use CloudFront to accelerate and speed up access to our content. So I did a demo in the last module about an S3 static website. Let's go and make access to that a lot faster using CloudFront. So I'm in the AWS Management Console, and let's get into CloudFront. So to get to CloudFront, we can search CloudFront. So here is the CloudFront Management Console, and right here I have a website already configured, or a CloudFront distribution configured to serve my static website. So let's jump in and take a look at that configuration really quick. So if we look at the configuration here, what CloudFront gives us is it gives us this domain that we can use to access our web page. I'm not going to access it yet, I just want to show you guys the configuration with the origin. So I'm going to copy that really quick. On the next tab, here you can see the origin, and this is the origin, which was our static website we hosted in S3 in the demo in Module 2. All right, so let's go and look at the comparison. So I'm going to reload the web page that we have served out of S3. I'm going to jump over there right now. I have the console up, and we can see how long it takes to go and retrieve this content. Do a quick little refresh. Right, if we do a refresh, what we can see here is right here, it takes 584 milliseconds to go and get this request. Now let's see how fast it is with CloudFront. So on this tab, I have here, this is our CloudFront domain. Let's do a refresh on this and see how fast this loads. Right, and I did that refresh. You can see now it's 127 milliseconds. So instead of going all the way to North Virginia, which is where my static website was located, here with CloudFront, we can serve it out of an edge location here close by to us. Another service is Amazon Elastic Cache. Amazon Elastic Cache is a service that makes it easy to deploy, operate, and scale an in-memory data store, making it easy for developers to set up in-memory infrastructure to accelerate their applications. Today, you have options between Memcached, which is great for applications that need to cache that support large amounts of concurrency, and Redis, in which you need data persistence and more advanced data types and features. So how can we put it all together to go and build a media streaming service? To process and prepare our media to deliver, we can use Amazon S3 to create an ingest S3 bucket to store and trigger a workflow whenever new content is uploaded. That workflow can be powered by AWS Lambda, in which it will generate extra metadata and store it in DynamoDB sitting behind Elasticache for Redis to enable faster search. To process the content for delivery, we can set up an SNS topic that delivers messages to multiple subscribed AWS Lambda functions to transcode our video from source format to high quality 480p, 360p, and audio-only formats stored in a playback S3 bucket behind CloudFront for faster delivery to our customers. In summary, we talked about various cloud-native or serverless services you can use to build your applications. Amazon CloudWatch for monitoring and metrics, ELB and autoscaling to achieve high availability and cost optimization when scaling out when we need more and in when we don't, AWS Database Services to store our data such as RDS and DynamoDB, AWS CloudFormation and AWS Elastic Beanstalk to automate infrastructure deployments, AWS Direct Connect for faster, more reliable connectivity to AWS data centers, Amazon Route 53 for DNS hosting, AWS Lambda to run code without managing servers, and Amazon CloudFront for content delivery. Thank you for your time. Next up is security with my colleague Sander.